Some of y'all are probably having some nostalgia if you worked in this area before. This is an old light. It's actually high-end systems. Well, I think this one is oh yeah, it's a high-end systems, but it's a sticker on top of it, and you still have an LR for Lightwave Research, company out of Austin, Texas. And then of course they changed their names to High-End Systems and eventually got bought out by ETC. A really nice company. Nowadays you see all the moving lights. They came from not necessarily this, maybe a company called Verilight and some other patents around the world. Verilight was one of the first. It was probably, if you think about it, Komar and drawing a blank on some of the other old school guys. This was one of the first inexpensive moving lights, but instead of a moving head, it actually had a mirror. And I'll flip this over around in a second so you can see. Stumbled upon about at least 10. If I'm wrong, there's probably like 16 of these things. And I've been cleaning them up and testing them out, and most of them actually do work. Like I dusted this one off. I haven't fully tested it yet. Won't go through all the functions with y'all. Just wanted to open it up and show y'all the guts. Ultimately, what I want to do is retrofit an LED into this. There isn't a kit out there because these guys, well, ETC now, they don't want you buying these things. There's a lot of people saying different ways to retrofit these things, and different people saying different reasons why you can't. But when I see that kind of thing on a forum, that usually means a lot of people are pretending they know what they're talking about, but they don't know what they're talking about. Honestly, when I dive into this, I don't know what I'm talking about. I didn't build this thing, so, but I'm gonna figure it out. We're gonna dive in, we're gonna open it up and have some fun. Maybe something will catch on fire, which would be pretty awesome if I get it on video. And even if I completely fail, I don't know, we might smash this or set it on fire. Might turn into a good barbecue pit. I don't know. Here's the head, body. It looks like extruded aluminum. It's easy. You don't have to build a box. Just spit out some aluminum pipe and build the guts around it. So here's the business. Not sure if you can see that. We'll turn it. This is the money side. You got your lens. All your guts are in here. So the light, bunch of electronics and stuff, and this little guy right here. Sounds a little crusty, you probably need to clean it. You know, I just bought this guy. So, you know, no brand loyalty, but just had everything I needed. It cleans contacts and it lubricates. So what is this? DeOxIt D5, the D series. So yeah, open this thing up. Old school circuit board, a lamp, and it's a little old xenon incandescent bulb. These wheels right here, one has color, one has gobo, and there's actually a shutter in here. And then of course, the lens. And then of course shoots down this mirror, and you see all these fancy stuff. Verilight owned the patent for the actual full moving head for a long time. So until that patent ran out, you didn't really see moving heads out and about very often. And you couldn't buy the light either. You had to lease it. Yep, and a lot of times you had to lease their engineer or pay their engineer to be on staff on tour with you too. Here's the DMX. DMX has been around forever. And it's still used. It's used in architectural lighting. So I see some home lighting. I know Philips Hues and the Zigbee systems have been taken over as far as homes go. But these guys, DMX was like a universal agreed upon standard, and it still is used in a lot of systems for home and architectural lighting. Dip switches, usually on a modern one, you'll see like a touch screen. We're gonna open this thing up and see if we can make it work. This was originally built in Austin, and there was a company called Lightwave Research. I need to go and actually look up their history, but from when I was a kid, what I understood was they started making dichroics. It's this, you can kind of see it down here, the colored glass. And it's not necessarily colored glass. It was vaporized metal on top of glass, and it was actually true filter. So if you think of colored glass would be like coloring the glass, versus this actually blocks certain colors out and lets certain colors out. So when you look at the reflection, it gives you two different sets of colors versus looking all the way through. I think probably one of the most popular things at the time that started using them were Oakley's glasses, and then it kind of spread up out there. But they were mainly making that, and it was a big old factory doing dichroics, and they started diving into intelligent lighting. This thing is probably 30 years old, and I'm pretty sure it still works. And if it doesn't, it's pretty easy to work on too. Most of the technology has not changed, just kind of slight upgrades, but the basics of it have not changed much. So the way DMX works, it's a 8 or 6, I think now it's a 16-bit signal. Well, it's been a 16-bit signal for about 20 years, and it goes through values, like we'll just say 1 through 256. It goes from all those values, and those values, the computer, onboard computer, processor, controller, whatever you want to call them now, they control different functions of the light. So you'll have the dimming function, so the color wheel, on this it's a gobo, shutter speed or strobe, focus, and X and Y. If you could see the mirror, I'll move it back a bit. Yeah, X and Y on the mirror. And then now it's going to be X and Y on the moving head. Focus, if you got it, intensity, color. Now you got true color mixing. It's pretty awesome. Yeah, it hasn't really changed much. Now componentry is simpler, cheaper, smaller. I set the dip switches on the back just to go to test mode, and we'll just see how it works. It looks like it's running through its functions. We're just going through the colors. Now the strobe. I think it went through the gobos. Now it's testing the XY functions. I think it's trying to find itself. So what it does is it goes all the way back or all the way forward until it calls itself 0. And sometimes it's a physical sensor, sometimes it's an optical sensor. I haven't looked inside the guts lately, so I can't really tell you right now. But once it finds itself, it goes back and forth and it tests to make sure it goes in the functions. Does this have a focus? No, this one doesn't have a focus. Shutter speed again. I think it's running through the functions again. But hey, it fired up. And this thing, from what I understand, is this hasn't been used in 15 years at the minimum. And it's easily 30 years old. What I want to do is figure out what's going on with this light, because we want to replace it with an LED. There's nothing out there to replace it. I found some drop-ins, like bulb size and some of the initial specs, but they're not as powerful as this thing. This is a 24 volt. Can't figure out if it's AC or DC, and that's what we're about to figure out, if this cheap voltmeter works. This thing goes up to, I believe, 7,200 or 7,500 lumens by design. The only drop-in LED lights that I could find, of course, just checking on Amazon, is, I think, 500 lumens. And then anything more powerful than that, they're huge. As far as like for cheap stuff I could find and on Amazon without me building anything. Most of the bulbs I'm seeing online that are really cheap, that I could drop in here, that have the amount of output pretty big, and plus not all of them dim. And LEDs are a little different than incandescents. You can have AC inputs, but usually you got some control circuit, usually a big old transformer, and it's converting it, and it allows it to talk to or power the LED without it burning out, because it's not like a regular light bulb. And that's basically what I'm trying to figure out what's going on in here. I know I could build something from scratch, but I think it'd be kind of fun to slap some stuff together and see what works or doesn't in the process. I highly doubt I am gonna break this. I'm gonna probably burn out a lot of LEDs before I burn this thing out. I especially like equipment that's either really open, where you dive your fingers in, and or modular, where it's designed to be opened and pulled apart and replaced really fast. So then you have a bunch of spare parts in a box in the truck, your work, or the back of the shop, or whatever it is. You got a bunch of spare parts where it's just ready to rock and roll, and you just plug them in and go. Then you can fix circuit boards at the shop or send them off to the factory and, you know, get for a trade-in repair on them or whatever. And you don't have to think about it, because as far as like entertainment and film and studio, a lot of times you're more needed on the set, on the stage, operating equipment, making sure things don't fall apart. What I'm gonna do here is, on the light, I'm gonna test the leads on the light. I'm gonna test for the voltage. I wish I could test out amps, milliamps, all that wonderful stuff. But I wanna see if this is DC or AC. When you're trying to find AC or DC voltage, especially cheap voltmeters, if you start off testing in DC on an AC circuit, then you might burn out the voltmeter. And this is not a really big fancy voltmeter, so I don't want to break it, and it's late and everything's closed. You start off by testing AC. If you see anything popping or not, we know the light works, so we know there's some sort of electricity coming through. And if we get numbers popping up on this thing, then it works. Then it's AC. Now, if we don't, then we swap over to DC and we see what kind of voltage we're going. Hopefully that works. Don't have clamps, which would be awesome, and didn't think about that. So here we go. So we're not seeing anything, but it might be the contacts I'm using. We'll test for continuity. Actually, it looked like I didn't have these plugged in all the way, so we'll do it again. And we'll test those little slots that I had. Maybe those will work. I put it to the highest voltage, and we go from there. All right. So I'm getting a voltage, 23.8 to 24 volt lamp. So yeah, that's it. It's AC. So that's gonna tell me what kind of circuits I'm gonna need when I start building LEDs for this thing. So that also tells me how it's dimming, and if I have to build my own power supply, what kind of circuitry I'm gonna have to build, design, or maybe I can find something that's already built and get, because there's different ways to dim. I'm not going into that. Just showing you the insides of this machine and me testing.